right, today we're learning section 11.1, which should be on page 533 in our books. I see pretty much everybody's done that. Okay. All right, now, the definition, the first thing you need to know is the definition of a square root. Okay, what is the square root of a number? What does that mean? Well, a square root of a number is a number that when multiplied by itself gives another number. Okay? So the square root of 64, does anybody know it? What's the square root of 64? It's 8. And is it true? Okay, so 8 is the square root. Is it true that 8 times 8 equals 64? Okay, so that's what the definition is saying. What about 81? What is the square root of 81? 9. It's 9. And is it true that 9 times 9 is 81?
Yes, ma'am.
Okay, so I'm multiplying that number by itself. Not by 2, but by itself. What about 36, class?
6.
6, and 6 times 6 is 36. What about 4?
2.
2, and 2 times 2 is 4. All right, so the square root of a number is a number that when multiplied by itself gives another number. All right, that's basically what it is. All right, now we need to talk about perfect squares. Perfect squares are numbers that are squares of integers, such as 1, 4, 16, and 25. If you can multiply a number by itself to get another number, that number is the perfect square. So 4, I would say, is a perfect square because I can multiply some number by itself to equal 4. Same thing with 9 and same thing with 16. All right, so can somebody else give me another example of a number that would be a perfect square? That is this number. With this number, I can multiply some number by itself to equal that number. So what's another perfect square? Can anybody think of one? Anyone? Krista?
36.
36, because what number times itself equals 36? 6 times 6. What's another one? Brandon? 81. Well, yeah, because we just did that one. 9 times 9 is 81. John?
144.
144. And what number is the square root? It's 12. Very good, because 12 times 12 is 144. Jonathan?
100.
100, because 10 times 10. Anna?
49.
49, because of 7 times 7. All right, so those numbers are perfect squares. Is 55 a perfect square? No, it's not, because there's no number that can be multiplied by itself to equal 55. 11 times 5 is 55, but that doesn't meet the criteria. All right, so now radical signs. Let's talk about radical signs. The actual radical sign in and of itself is positive, okay? So if you see something like the square root of 4, well, you're taking the positive square root of 4, and that would be 2. Unless there's a negative out in front of the radical. The negative square root of 4, I'll give you one guess. What is it going to be? It'll be negative 2. Okay? So if, and you're going to see this in the example, if we say evaluate the square root, and there's a negative out front, then the square root is going to be negative. If there's nothing out front, then I know it's going to be positive. All right? Now let's move on to example 1. So if you haven't been writing, you need to start writing now. Okay. Okay, you're going to have problems like this on your homework and on your quiz and test, where it says find the 2 square roots of a certain number, the 2 square roots of a number. Well, here's what I mean by that. We know that the square root of 81 is what?
9.
It is 9, okay? But is it true? So, because 9 times 9 is 81, right?
Yes.
But is it true that negative 9 times negative 9 is also 81?
Yes.
Yes, it is. Because I multiply a negative by a negative, that's an even number of negatives, it's a positive answer. So when I say the 2 square roots of a number, the 2 square roots are 9 and negative 9. And I write that as a positive and negative 9. The positive and negative are stacked on top of each other out in front of the number. All right, so if I asked you, what are the 2 square roots of 81? your response would be positive and negative 9. All right, and do you see why? Because negative 9 times negative 9 is also 81. They both are 81 when you work them out. Now, this part of it, where I'm actually showing the work, you don't have to do that on your homework, okay? You don't actually have to write that. I'm just showing you that's why. That's kind of a little bit of the background information of why. All right, so given that, I want you to find the 2 square roots of 49. There's no work to show. You just write it right there on your notes. You tell me what are the 2 square roots of 49. All right, Adam, what do you think?
Positive and negative 7.
Very good. Positive and negative 7, and that's how you should have written it on your paper. Did everybody write it that way? With the positive, negative stacked? Okay, positive and negative 7. All right, so that's it for example 1. Any questions? All right, so now example 2. Now in example 2, we're evaluating the square roots. So the radical is already there. Okay, so the directions for a problem like this would say evaluate the square root. Evaluate the square root. So the square root of 36 is what? Just 6, because the radical is positive unless there's a negative out front. What about square root of 16? 4. Make sure that you're taking the square root, not dividing. What about the negative square root of 16?
4.
What about the negative square root? It is no, not positive and negative, just negative. It's negative 4 because of the negative that's out in front of the radical. Okay? Remember, the radical is positive, so if that's in your original problem, you know that you only have one answer. What about the square root of 0? Just 0. There's no such thing as a positive or a negative 0. All right, and what about the negative square root of 625? What do you think? Krista?
Negative 25.
Negative 25. Someone raise your hand and tell me, why is it negative 25, not positive 25? Tyler? Very good, because there's a negative out in front of the radical. All right, so for these where you're evaluating the square root, make sure you're watching for that negative. All right, any questions on example 2? Any questions? All right, now for example 3, I want you to turn back to page 533 and read the pole vaulting example with me on page 533. It says, how fast should a pole vaulter run to vault over a height of 16 feet? So you all know what pole vaulting is, right? They have the pole on their shoulder, they run, they stick it in the ground, and they flip themselves over a bar. Okay, so how fast do they need to be running to clear 16 feet? All right. Now, I'm not saying that this is the most realistic example, but just bear with me. So in example 3, it says to find the minimum speed, we're going to use this formula. S equals 8 times the square root of h. It's nothing you have to memorize. It's just that's the equation that they're giving us to use to solve. Where S stands for speed and h stands for height. Okay, well, what was the height again?
16.
So S equals 8 times the square root of 16. Well, what's the square root of 16?
4.
So 8 times 4 is 32 feet per second. Feet per second, which is like totally unrealistic. I don't even know if a car can drive that fast. I mean, I guess maybe, but obviously it's not realistic for a person to produce that kind of speed. But regardless, do you understand how we substituted? You understand how we substituted and solved? All right. Okay, so that's it for example 3. I want you to do numbers 1 through 8 very quickly. Just numbers 1 through 8. Your turn now on page 534. All right, someone raise your hand and tell me what is the answer to number 1. Jonathan?
3.
No. Positive and negative 3. Very good. Positive and negative 3. What about number 2? John?
Positive and negative 8.
Very good. Positive and negative 8. What about number 3, Vanessa? Positive, negative 10. Very good. What about number 4? Brandon?
Positive and negative 13.
Very good. Positive and negative 13. What about number 5? Adam?
15. Under 5.
Yes, very good. 5. What about number 6? About number 6, Tyler? There's a negative out in front of the radical, Danielle. -1. Very good. What about number 7? What's number 7, Isis? -12, because there's a negative in front of the radical. And last but not least, number 8. Garrett? It is just 11. Very good. All right, now in example 4, we are evaluating radical expressions. And notice that they give us some information that's important to know in the directions. What does Z equal? What does Z equal? 7. What does M equal?
2. -2.
-2, okay? So what I'm going to do is I'm going to substitute, and you've heard me say this before, I'm going to substitute the value for the variable, and then I'm going to evaluate. So now I have 29 plus 7, so that's going to be the square root of 36. Do you see where I got 36 from? What's 29 plus 7? It's 36. And then what's the square root of 36? It's 6, and that's my answer. I got 7 because Z equals 7, and I plugged 7 in for Z. Okay, yeah, that's why it's important to read the directions. Now I want you to evaluate the square root of 4h minus 8 when h equals 11. When h equals 11, okay? I just made that one up right underneath. I want you to evaluate the square root of 4h minus 8 when h equals 11. All right, Chandler, what do you think? Do you agree with him?
Yes.
Okay, because when you substitute, and here's what I want to make sure you're doing. Leave it under the radical until you actually take the square root. Okay, so you see how I left the radical above. Now I'm taking the square root of 44 minus 8, which is the square root of 36, which is 6. Okay, so I want you to keep that square root sign over the work that you're doing until you actually take the square root. And here's why. You might get to the end and say, oh, well, my answer is 36, and forget to take the square root because you dropped your square root sign too early. Does that make sense? So keep it until you actually take the square root. Now, in the second example, it's just a little bit more detailed, but I'm still using the same numbers. 7 squared because Z equals 7, plus what does M equal? -2 squared plus 11. Well, what's 7 squared? What's 7 squared? 49. What's -2 squared? What is it? It is, nope, it is just +4, because what is this saying? It's saying -2 times -2. Negative times a negative is a positive. 49 plus 4 plus 11, that's going to be the square root of 64, which comes out nicely to an answer of what? 8. Okay, so just plugging in the numbers and evaluating. That's what we're doing in example 4. Now, in example 5, okay, we're solving equations using square roots. Now, remember how I always taught you in the previous chapters, you have to do the opposite operation to get the variable by itself? You remember me saying that? So if multiplication is connected to my variable, like for example, if I had 3x equals 15, how do I get x by itself? Brandon? I divide by 3 because here I'm multiplying 3 times x, so I have to do the opposite operation to solve. Everybody remember that?
Yes.
Okay, so with, let me go back to example 5 now. So with this, I still need to get x by itself, except this time, x has the exponent of 2. So how can I get rid of a squared variable? Well, I still need to do the opposite operation. So I have, I'm just going to write it a little bigger. I have x squared equals 25. To do the opposite operation of a variable that's squared, you need to take the square root. Take the square root. So to get x by itself here, I need to take the square root of x squared, and that will give me x. Okay? because x squared is basically x times x. But if I take the square root of one side, what do I do to the other side?
Do the same.
I have to do the same thing. All right? Now here's what the rule that you need to remember. When I take the square root of the other side, I am taking the positive and negative square root of that number. You just need to remember that. So x equals positive and negative 5. And here's why. Because if you were to plug in negative 5 here, what's negative 5 times negative 5? Positive 25. So it still checks out. And then 5 times 5 is 25 too. Okay? So with both answers, the positive and negative, it checks out. If you're lost, all right, just hang in there with me because we're going to do several more after this next example. Now, for example B, I have h squared plus 5 equals 54. Does anybody think they have any idea what I need to do first in solving for h? What do I need to do first, Garrett?
You need to do h2 plus 5 minus 7.
Okay, I need to subtract 5 from both sides. I want to get rid of everything that's not attached to my variable. Now I have h squared equals 49. So now, how do I get rid of that h squared again? How do I get it to just h? Anybody remember what I just said, Gage?
Put the square root on
Very good. I need to take the square root. But whatever I do to one side, I have to do to the other. And remember, it's the positive and negative square root that I'm taking. So h equals positive and negative 7. And that's my answer. All right? And if you understand that, that's everything you need to know for 11.1.